Hello, this is Mr. Arnold, and we're going to talk about some chemistry notes here today for STEM class. I'm going to start over this chapter. We just did one day of lecture, and so if you already know how to count the atoms and you were there that day, then you've already done this lesson. If you make sure that you have turned in your Count the Atoms worksheet, and that will be this lesson today. Chemical formulas. Okay, a chemical formula is a way that we know exactly how many atoms of whatever element it is in a particular formula for a chemical. Chemists like to know what it is. We don't want to go around just calling it by a common name, like, for instance, water, right? Water, the chemical formula is H2O. And that tells us exactly the number of atoms there are and the kind of atoms are in it. This little number down here, this is called a subscript. And so it comes behind the element that tells you how many it is. So there's two H's. There's also an invisible subscript right here for oxygen, which is the 1. And in chemistry, the subscripts are, if they're 1, it's optional. You don't have to write it down. You could still write it if you want to, but it's optional. Okay, and so that's what our chemical formulas are going to look like. Here's another one. This is ammonia. Ammonia is the stuff that we use to clean windows, window cleaner, Windex, and it's NH3. Right, so that's just common formulas. Carbon dioxide. And so then we use these formulas, instead of writing out the names, we use these formulas instead. So chemistry is kind of like a little language, and we're just going to talk about this language in this section. All right, there's different kinds of bonds. There's two main types of bonds, and they are ionic and covalent. Ionic bonds transfer electrons. Now, that's the term we like to use, transfer electrons. There's two charged particles, two charged ions. An ion's a name for a charged atom. And because they have charges positive and negative, kind of like a magnet, they stick together. Let's do our favorite ionic compound, which would be table salt. Na, and I'm going to draw the electron dot model. Na had 1 electron in its outer shell. If you remember this from a while ago. And Cl has 7. All right, now, Na is not happy because it has 1 electron in its shell, and it would like to either have 8 or 0. Cl is not happy because it has 7 electrons in its shell, and it would like to have 8 or 0. Now, the way we know what they're going to do, it's the easiest way, right? It's much easier to lose 1 electron than it is to gain 7. And for Cl, it's much easier to gain 1 than to lose 7. And so what's going to happen is this electron right here is going to transfer over to the place it's wanted. Now, that gives Na a positive charge because now it has 1 less negative particle. And that gives Cl a negative charge because it has 1 extra negative particle. And now, because opposites attract, positive and negative, they're stuck together. That's an ionic bond. With those kind of ions, sometimes we have atoms, or a group of atoms. That's poly means many, right, or group. We have a group of atoms. Look, poly, group, atom, ion, with a charge. So we get a group of atoms that are bonded together, but they also have a charge at the same time. Now, I'm going to draw something. I'm going to draw it over here. This is a common polyatomic ion, is what we're going to call it. Let's start with S. Okay, S has 6 dots. Now, how do I know this? Remember, look back on your periodic table. Oops, wrong table. S was right here, number 16. And if you go up on your table, look what we wrote. 6Ve. That means it has 6 outer shell electrons, 6 valence electrons. Okay. And we're going to bond it with oxygen. And oxygen is right there with it. So oxygen also has 6 valence electrons. Okay. So we're going to bond this with 4 oxygens. So oxygen has 6 dots. And if I put them together like this, I have a full shell. I have an octet for that oxygen. So I'm going to go all the way around and put those together like that. Now I'm going to do this one too. And watch what happens. 1, 2, 3, 4, 5, 6. I'm missing a dot. I'm going to do it again. 1, 2, 3, 4, 5, 6. I'm missing a dot. So this right here, this compound is missing some electrons. So what are we going to do? Well, there's plenty of electrons out there, right? They're everywhere. So this thing wants electrons so bad the oxygen is going to grab some more electrons and fill up those empty spots. When that happened, now we have 2 extra negative dots, 2 extra negative particles. And that gives this whole thing a -2 charge. And I know what you're saying. Mr. Arnold, what were you even talking about? Well, I was talking about a group of atoms, SO4, that just happens to have a charge, -2. Now, when we have a polyatomic ion, we always put it in parentheses so we know that it's a polyatomic ion. So when I write it out, it's not quite like a regular chemical formula because now this is just going to be a part of a formula. Now it's in parentheses. I have 1 S, there's an invisible 1 right here. I have 4 O's, but I have 2 extra electrons. And so it has to have a negative charge. And because we want everybody to know that the whole thing has this charge, not just the O's, not just the S, but all 5 particles, we put it in parentheses. That's going to come into play later, and you'll like it once we start using it. Okay. All right. Covalent bonds. Covalent means share electrons. Now, I've already drawn some sharing when I did that polyatomic ion, right? I showed the sharing over there, but let's do one that shares a little bit more easy to see. Let's do water. Okay, remember it was H2O, so we have an O. O has 6 dots, so I just looked on that table to find those dots. Remember that? And then H, each have 1 dot. Well, look here. It's going to fill in those spaces. Now, what's happening? Why are we doing it this way? Well, hydrogen really, I'm going to say it another way. Oxygen doesn't want to give up any of its dots. It has 6 dots. It wants to gain dots. So it has a strong hold on those electrons. Hydrogen also doesn't really want to give up its dots. It has a pretty strong hold on its electrons too. And so what happens is they have to, instead of being able to rip them away from each other, they end up having to like share them in between them. They can't quite get it away. Now on water here, the hydrogen and the oxygen are battling for those electrons, but oxygen's much tougher, much stronger. So really, the electrons are going to spend more time around that oxygen, making it have a little tiny positive charge on one side, not a full charge, and just a little negative on the other side. And we call that polar. Polar is when they have, we'll say, a covalent bond has, a covalent bond has a small charges on the ends. Right? And if you think about polar, what does polar mean? It doesn't mean that it's cold. Polar means that it has sides. The North Pole, the South Pole. It's the top of the Earth. It's the bottom of the Earth. And what are they? Poles of a magnet, right? Poles are the sides, the charged sides of things. Another covalent bond would be CO2. That's a little tough. Let's do methane. That's one of our favorites, right? And methane was CH4. The carbon had 4 dots. Each H had 1 dot. And again, they both want to hold on those electrons. They don't want to give any away. And so what happens? They end up sharing them. And so when you see these little pictures that we draw like that, like this, and like this, right? Those are the molecules. We can also draw pictures with the ionic bonds, but they're not. It's just not quite as helpful. So most of the things you'll see will be molecules when they're drawn in the electron dot form. Now I just said this word twice. Molecular formula. Okay, that's just the cue for covalent. So if it's a water molecule or a carbon dioxide molecule, that means it's a covalent bond. They're sharing electrons. Okay. All right. And that's our preview. All right, now we're going to count these atoms. And I know this should be pretty easy to do. And then I'll stop at this point and I'll do a different video for the mass. I know that we started talking about that down there, but we didn't quite finish it. So let's look at this picture here. We have H2O. Well, I look at that and I say, oh my gosh, there's 2 H's and 1 O. Remember, invisible 1 behind there. Carbon dioxide is our CO2. Right? There's 1 C and 2 O's. Okay. Aluminum, and this is called acetate. Now, you don't have to know how to name that yet, but I've just been saying names, so I'll just keep going there. Now, we know the alumins. We know there's 1. But look at this. That's a polyatomic ion right there. And so we have a 3 outside that parentheses. Right? So what that means is that we have 3 of everything inside that parentheses. So we don't just have 2 carbons. We have 3 sets of 2. Right? So that would be 6. We multiply. We don't just have 3 hydrogens. I'm switch colors. We have, I'll go up high. Woo, boop. We have 3 sets of 3, which is 3 times 3, which is 9. We don't just have 2, I think you got it now, don't you? We don't just have 2 oxygens, we have 3 sets of 2, and so that would be 6. And so our numbers that we have would be 6 carbons. Let's color code that. 6 carbons and 9 hydrogens and 6 oxygens. Okay, so I'm just multiplying that by the number outside the parentheses. Okay, let's just see if we can do this in our head because it's a lot funner that way. So we have 2 times 1, so we have 2 nitrogens, and 2 times 4, that's 8 hydrogens. Now there's no number out here this time. That number's inside. So there's 1 set of 1 S, and 1 times 4 for the oxygen. So you got to watch where that little number is, where that subscript is. Okay, we have 1 SR and a 2 outside, so 2 and 2. We have 3 CAs because of this 3 here. And we have a 3 outside, so we have 3 Ps and 12 oxygens. Okay, now there's a worksheet that's on Schoology, and I'm going to call that worksheet, and some of you guys have already done it. And so it's going to be counting the atoms. And we're going to call it STEM for STEM class, 2 for the second 9 weeks, /1, first assignment. Okay, and then I'll do this whole 9 weeks this way because we don't know when we'll be back. I know we're supposed to be back in 2 weeks, but we may not be. And that's right at Thanksgiving break anyway, so it's close. And so what we'll do is we'll just keep this whole 9 weeks this way. I'll have the regular name. I'll have STEM 2.1. That'll be the first assignment of the 9 weeks. Then counting the atoms, we'll have the name of it so you know which one it is so you can find it. And then I'll keep that in Schoology in order so we can find our assignments a little bit easier. All right, well, I think that concludes the first lesson. And for you that have it already turned in, I'll have that in the grade book. I did the other 9 weeks first, so I didn't put the new ones in yet, but I'll have that in the grade book probably Monday, probably tomorrow. And then you'll know you don't have to do it. And then we'll do finding the mass tomorrow as our lesson. And we'll call that, the finding the mass will be STEM 2.2. All right, and then we'll just move through this chapter and we'll keep breaking it apart. And just keep up, don't fall behind. They're doing attendance by your progress in your classes. So if you fall behind, there's going to be, I have to do due dates. So we'll make counting the atoms probably due Tuesday. We'll give you 24 hours. It shouldn't take very long. No, the other kids just did it in class. It took them about 10 minutes. And then we'll make a due date for the finding the mass. And you have to turn them in on time because that's how they're going to do your attendance this time. All right, well, that's it for me today, and hopefully we'll see you soon.